What's up, everybody? Welcome to this video. Today we are looking at analytical geometry grade 11. Please make sure that you do view the lesson so that you will be able to understand this one. This one is an exam question. I think it's from 2018 past paper. So let's have a look at it because I have seen that a lot of examiners, this is what they are using these days. They try to bring analytical geometry together with Euclidean, and then it just causes a mess. All right. So, but we are here at Maths with Catherine. We'll make things happen for you. We are gonna unpack this question for you. Please make sure that you follow. And if you don't follow, you can leave a comment and let us know how we can improve our lessons. All right. Okay, great. So now let's have a look at this question. Question number one. Okay, that's a wrong way to start a question, but let's go back and read the question and make sure that we fully understand what is going on here. It says that in a diagram F, it's given by the coordinates 2 minus 2, G is 5 is to 2, and then C, it's 6 is to Y. We don't know the coordinates of C. We're probably the one to ask us for that. Okay, and then they said these are the vertices triangle FGC. Okay, we see that. And then they say to us FG is perpendicular to FC. Okay, I think this is very, very important. FG, where is FG? Yes, FG is perpendicular to FC. FC. Okay, great stuff. Okay, we understand that. So this simply means the gradient. If they talk about perpendicular, we know that the product of the gradient of these two lines should be able to give us -1. And therefore, they also say here N is a point on FG. Okay, we see N is there. And then such that it forms the angle of inclination and C. Okay, angle of inclination. We know that the angle of inclination, based on our notes, we know that the angle of inclination is the angle that is formed by the line with the x-axis. Okay, the angle of inclination of FG, which is also this one here, beta, it's is the angle that is FG. It's forming also with the x-axis. Okay, and then also with and also we have got FN, N, which is angle theta. Okay, great. So there's no need to panic. We see the diagram, we fully understand it. Angle of inclination, things that we need to take note of. Angles on a straight line that equals to 180. Therefore, we also need to know angle on a straight line from Euclidean geometry. You remember this, guys. Angle on a straight line, they are equal to 180. And then we also know that from a triangle point of view, the exterior angle of a triangle is equal to sum of internal opposite angles. So therefore, this angle right here, let's say this is theta. Okay, let's say this is angle A rather. It's equal to angle B, which is this one, angle B, and also angle C. Is angle A is equal to the sum of those two angles. All right, great. Exterior angle of a triangle is equal to the sum of the internal opposite angles. Okay. All right. So let's have a look at question number one. In this case, it was question is for 2 marks, 4.2. It says then find the gradient of AFG. Let's go here. FG is going to be equals to y2 minus y1 all over x2 minus x1. All right. Let's see FG. FG. Now, then we need to write the coordinates. Here they are. Okay, let's assume that this is coordinates number 1. This is coordinates number 2. So therefore, y2 would have to be -2. And then y1 will have to be minus y1, which is 2, all over x1, which is okay, wait a minute. Okay, I swapped them around, but it's fine, guys. It's fine. 2, and then therefore minus no, I didn't actually. Okay, -5. All right. So therefore, if you punch this in your calculator, your gradient, you should be able to get to, let me see, on the top there's going to be -4. then at the bottom is going to be minus 3. So you should be able to get minus 4 minus 3, which will give you minus 4 over 3. Okay. All right, then that's how you deal with that, and you will just have to apply the gradient formula. Okay, and then they said calculate the value of y. Y is here on C, so we need to calculate the value of y. So according to this, from the information that is given, it says that the gradient from this information here, we know that this is 4.2. The gradient of fg, or the product, should give us fc is equals to minus 1. Okay, so therefore, do we have the gradient of fg? Yes, we do. We just calculated it from the top. All right, so it's going to be 4 over 3. We need to be able to get the gradient of fc. Let's come here, fc minus 1. Therefore, we found this one, multiply both sides by 3 over 2, which is the same as dividing by it. This one would cancel out this side. Therefore, you are left with fc, which is equals to minus 3 over 4. Great. Okay, so now, once you have this, guys, you need to apply the gradient formula. You know what the gradient formula says. Therefore, so that we should be able to find the coordinates of y. Okay, so let's come here. We know what is fc gradient. We know it, y2 minus y1. Some teachers would say rather mark this in terms of the alphabet. If there's nothing wrong with that, you can come here and say y. Which y are you going to use? You're going to use y at c, which is the y you're looking for, minus the y of minus the y at f, all over x at c minus the y, no, sorry, minus the x at f. Okay, all right, great. Now let's do the substitution here. Minus 3 over 4 is equals to y at c is the y we're looking for. Okay, minus the y at f, we should be minus, there you go, all over x at c, it's 6. Okay, minus 2, which is the x at f. Okay, so with this, guys, we can do the algebra. Cross multiply, let's see, 3 over 4 is equals to y at c plus 2 all over 4. Okay, then we do the cross multiplication. Y at c should be minus 5. Okay, and that's how you would deal with this one. And then when we mark for you, you should be able to get full marks. All right, okay. Okay, let me come here for the sake of space. Let me write 4.3 here, so that the other space I can write 4.4 there. 4.3 says find the size of theta. Okay, so now here, that's where now your geometry comes in. All right, okay, we need to find theta. All right, first thing first that we need to do here, we need to be able to find beta. Okay, do we know the gradient of fg? Yes, we know the gradient of fg, and we know the relationship based on our first lesson on analytical geometry. Please, if you have not watched that video, if you're getting lost here, please make sure that you know how to link the gradient and the angle of inclination. But for the sake of understanding, it says that gradient should be equals to tan angle of inclination. Okay, so in this instant, we're looking for the gradient of fg. We already have the gradient of fg. Therefore, the gradient of fg, this rather in this case, it should give us beta, not theta. Okay, it should be given because is the gradient that the line fg, which is this one here, is forming with the x-axis based on the theory that we have discussed. Okay, all right, so this should be fg, gradient is 4 over 3. It's equals to tan beta. Therefore, you should be able to say beta it should be equals to second function on your calculator. Therefore, because you are looking for an angle, okay, so you should say second function, shift second function, and then you press turn, then you should be able to get that angle beta is equals to 53,13 degrees. Okay, and that's how you would deal with this angle theta, guys. All right, angle beta rather. So in order for you to find angle theta, remember what we discussed here. This is a triangle, this one here. Okay, let me try to highlight it here. This is a triangle, this one. Please check where I'm writing, guys. This is a triangle, this one. Okay, so let me just draw it here so that it becomes visible. This is triangle. Okay, there you have got this exterior angle here, which is 104.4 degrees. Therefore you've got theta here, therefore you've got also got beta here. But what did we say? Angles, exterior angle of a triangle is equal to the sum of the internal opposite. So therefore, it means in this case, for angle 104.0 degrees should be equal to the sum of theta plus beta. Okay, we already know what is beta. Therefore, when we substitute in this case, we are looking for theta. Beta we know it's plus 5315 degrees. If you put this on a calculator, you should be able to get to a situation where theta is equals to 50,19 degrees. Great stuff. Can you see? So in analytical geometry, when they start bringing a little bit of Euclidean geometry here and there, they can do this, guys, because this is geometry. So geometry, when you go to varsity, you will see that basically geometry is one course. So you do geometry alone. If you're gonna pursue a career in statistics, you should be able to do calculus alone as a course on its own, and geometry as a course on its own. So therefore, this is just the examiner trying to make sure that you are able to link the knowledges between the two, so that, because this is one of the things that we are testing when you go to metric as well. Okay, so this is just knowledge application. So please make sure that you stay tuned so that we will be able to assist you. All right. Okay, and then let's come here and say, okay, no, now we need to find the length of NC, NC. But we don't have the coordinates of N, they were not given to us. Okay, but for 4.4, I think we should be able to solve this equation if we found the distance of FC. Okay, if we found the distance of FC. Okay, remember they did give us a relationship between the two. Okay, let's find the distance of FC. Okay, because we did find the coordinates of FC there. FC is equals to square root. Okay, we know it's equals x2 minus x1 squared plus y2 minus y1 squared. Okay, so we know the coordinates of F. We come here and say F is going to be equals to, please, we choose what is our x2 and what is our y1. Okay, so in this case we have got 6 minus 2 close plus, and then we have got minus 5, which is what we calculated earlier, minus into minus. Wow, guys, this is where I see a lot of learners make mistakes. Minus into minus into minus. Now, please make sure that you put, when you substitute, you put your numbers in brackets, guys, so that you don't have any confusion when it comes to pressing the calculator or substitution, because minus can cause trouble. That is why negative, we don't want to be negative, we want to be positive. So please make sure that you very, very careful when it comes to the negative sign. Okay. Therefore, if you put this on your Casio calculator, you should be getting a 5 units. You should get 5 units. However, this is the length of FC. So with the length of FC, we should be able, because we know theta. Okay, this is where I said they're throwing us that sine rule, cos rule, because it's all about geometry. Okay, so but we know that for us to get theta sine, for us to get theta, when you look at this is a right angle triangle. Okay, this is a right angle triangle. Okay, let's come here and see. Let me just put it here so that you guys will be able to see it. A right angle triangle. This is N, this is where theta is. Okay, yeah, that's where theta is. This is C, and therefore this is F. Okay, so can you see that this is a right angle triangle? So if we know that this distance here is 5 units, we're looking for NC. We should be able to find this NC. Okay, so how would you find NC? You're going to say, oh, you can say rather, you can say opposite, which in this case would be opposite to this theta here, opposite angle to the opposite side of the theta, which is FC all over NC, which is our hypotenuse. Now we are dealing with Pythagoras theorem here, which is sine theta. Okay, so we know what is FC. FC, it's 5 all over NC. That's what we're looking for. And then is equals to sine. What we're looking for in this case, sine, we know that theta is equals to 0.91. Therefore, we do the cross multiplication here, do all the algebra. You guys are in grade 11. Therefore, you should be able to get to a situation where 6 is equals, NC is equals to 6.4 units. Okay, and that's how you would deal with this question, guys. Please make sure that you subscribe to our channel right here at Maths with Gastin. I am Gastin Mapala. Stay tuned. See you on the next upload.